Hello, Keith Rucker here at VintageMachinery.org. Guys, today I'm back to working over here on these tool holders, these custom tool holders that I've been making to go over on my Kearney Trucker Model 2D milling machine. I've got a couple of jobs, or a job coming up where I'm going to need some of these custom tool holders for do some tool holding for some things that I just don't have. And like I've talked about before, you just can't find this stuff, or at least it's not very commonly available. Nobody's making this kind of tooling anymore. So I'm gonna make some myself. So previously, I have got three things here that I need to kind of work on today. The first one here is just a taper that I've got set up that's at a 3.5 inch per foot taper, which is the taper for these tool holders to go on that K&T mill. This one here is just going to be a standard that I can use to set my machines up easier in the future, my taper attachments and my grinder. I'm going to grind this after I do a heat treat on it to that perfect taper, and then I'll have it that I can set things up with easier down the road. These are the actual two tool holders that I need. They have the same taper up here, a little bit shorter section, but same taper. We need to get this over to the grinder and get these ground, but before we do that, I need to heat treat them. These are made out of 4140 steel, and we need to go through a heat treat process to kind of make it a little bit harder. And before I do that, I actually got a little bit of machining work left to do on this particular cutter here. I need to tap the end bottom down here where a bolt comes in, and I also need to go ahead and cut a keyway in it before we harden it, because it'll be difficult to do that after the fact. So that's what we're going to be working on. We're going to finish machining these, do the heat treat on these, and then we'll probably come back and grind them in a separate video. So that's today's project. Let's get at it. So just a little close-up shot here of the different parts we're going to be working with today. Again, this is the one that we're going to have to do a little bit of machining on. All of these diameters, well, the important ones, this end as well as this end here, are oversized right now. I purposely made them just a little bit oversized so that we can have some material to grind off after we do the heat treat on. This one here just pretty much needs to be heat treated and then the collet end ground, and this one just heat treated and ground. And I went ahead and stamped this 3.5 inch per foot taper just so that I can know what that is later on. Again, after doing the heat treat, it'll be hard to do that, so go ahead and get it knocked out now. Let's go over to the lathe. I'm going to get this put in there, and I'm just going to use the lathe to hold the part. We're going to get this bottom tapped, and then, like I said, we're going to cut a keyway in there. It's going to be a little bit tricky, not crazy, but we're going to have to take into account the extra material that's on here when we figure up the depth of the cut, because that diameter is going to reduce in size when we grind it. All right, let's head to the lathe and we'll do our tapping. So I'm just using the lathe here for work holding. I've got this in the chuck, and it's just a good convenient place to hold this while I'm working on it. I'm going to put a little anchor lube in here for lubrication while I'm tapping that. And we got our tap here. This is a 1/2 inch 20 is the threads that we're going to be doing. And let me pull up my tailstock. I just got a tap follower in there that will just kind of help me keep everything lined up. This is spring loaded, so that should be lined up on the center. I've got my gear set for the lowest speed, so that's going to give me the most tension holding this in place. And we'll just feed that in. As I'm feeding in, I'll just tighten that up so that it stays nice and tight, at least until I get it started. Tap follower just kind of assures that it is lined up nice and tight on that, or nice and straight on that hole that we're tapping. All right, that's pretty much bottom there. We will extract that out. All right, we'll pull that out, and that step is done. Now let's go over to the mill and cut our key. I've got my part over here in the mill, in the vise. So we've got it clamped between the two vise jaws, and it's sitting on a parallel to make it sit flat across the bottom. I've already come in here and found the center. I just used an edge finder. I found the edge on one side, zeroed out my digital readout, found the edge on the other side, took that measurement and divided it in half, and that puts me right in the center of the shaft. Now, as far as depth of cut, like I mentioned before, this diameter is going to be ground down to 1.25 inches, but right now it is a little bit oversized. And to get to the depth of the key at its final depth, so we don't have to do any machining later on, I need to mill down 190 thousandths deep once we touch off on the top. So we're going to touch off now and do exactly that. We're going to cut that key in there. So let me fire up the mill. I'm just going to lower that down by hand. Since I did touch right there, I'm just going to back off a little bit. I'm going to raise the table up until we just touch right there. I'm going to call that 0. I will 0 that out on the digital readout. And we need to go up 190 thousandths. That's 190 right there. Now I'm going to do this all in one pass. I'm going to stop right there. That should be it. So there's our keyway, and we got a 5/16 inch key there that will fit in there just fine. So I think we're ready for heat treat. So I've got my parts here ready to go into the heat treat oven, and we're just going to go ahead and put them in here. So I'm just going to place these in here where I can get them out. I'm going to lay that one down on its side. I'm going to put that one in there like that. And I'm going to kind of put them close to the front door here just so I can get in there and grip them and get them out. A couple of things to note. I'm using a hot shot oven here. This is my heat treat oven that I use. I've got it programmed for 4140, which is basically the heat treat is we're going to ramp it up to, 1575 degrees Fahrenheit. Once it gets to that temperature, we're going to hold it there for an hour and a half. At that point in time, it'll give me an alarm to tell me that I'm there. We'll come over here, we're going to pull these out. We will quench them in oil. The oil will cool them down and harden them. After that, we'll go through a tempering process to actually soften them back up a little bit. And if I remember right, we'll basically put it in there at 600 degrees Fahrenheit for about 45 minutes and then let them air cool. That's kind of the process. I've got it programmed here ready to go. I'll also note this little here, I got a hose coming in here. I'm actually flushing argon into the oven, and when I close this, I'm going to leave the front door cracked for just a few minutes to make sure we purge all the oxygen out of there. Then I'll seal it up, and the argon basically is an inert gas, the same as you use for TIG welding. And the idea there is that you won't get any oxidation or greatly limit the amount of oxidation that goes on inside the oven while you're doing your heat treat. When you get the oxygen there, you get that scale on the outside of the steel. The idea here is if we remove all the oxygen from the oven, we purge it with the argon, you won't get the oxidation going on. So anyway, I'm going to just kind of come over here. We'll just leave that cracked a little bit. I'm going to get into my program and we'll start our program. Just go to my 4140 and hit start. It's asked me, do I want to delay the start? The answer is no. And all right, we are going. It is ramping up right now. It's at 78 degrees, which is where we're starting. And we should start seeing that number climb up here as it starts going. Just kind of see what's going on here. We're on the current step right now, which is going to be basically going up to the 1575 degrees. I've just got it ramping up as fast as possible. It's going to hold it there at 1 minute. There's my temperature. And then after that, it'll Basically, it's going to just keep it at that temperature for an hour and a half, and then the alarm will go off, and I'll know we're ready to go. So you can see it climbing up, and we'll just let this thing roll. We are approaching our 1575 degrees, which is where it should start holding it at. Okay, so we basically it's hit 1575. I've got a hold time in there for 1 minute. Just to kind of stabilize it, so we should kind of be stabilized at 1575 now. And then after that 1 minute goes by, it will should start a countdown for 1 hour and 30 minutes. And it's, the temperature, it's going to keep it within, 5 degrees, give or take, of that temperature. It's pretty accurate. Typically, once it kind of gets stabilized, it just hit that number, so it's still kind of stabilizing in there right now, but it's going to keep it pretty darn close. So let's let that count down the next 10 seconds here, and we should again see the timer go to 1 hour and 30 minutes, which is how long I want to hold at 1575. There we go. All right, so we got an hour and a half to kill, but the oven's doing its job. Well, guys, our time is up here. We've ran our program, and I'm ready to do my quench. So I'm going to go ahead and pull the parts out. I've got some oil down here that we're going to quench this in. I'm going to do one at a time, and we'll just open and close the door as we do this. So I'll just open that up. We can see our parts in here. I'm going to grab the first one I come to. I've just got some blacksmithing tongs here, and we're going to quench that in there and just move it around in the water. And make sure it's good and cool before we bring it out. And I got some pads down here on the floor that I can just drop the parts on, where I'm not going to drip oil everywhere. So. And there's the first one. So grab our second piece here. Got a little oil dripped in the oven. And quench this one. So for the tempering, we're going to put the items back into the oven, and we want to be at about 800 degrees for this, and it needs to soak at 800 degrees for about 45 minutes, and then after that we can pull it out and just let it air cool. So I'm going to put the things back in the oven. I've got a program running. We're a little bit on the hot side right now, but it's going to cool down. It's actually dropping. We're at about 890 degrees right now, but it's dropping down. So, and it's programmed to keep it at 800 degrees. Like I said, we're going to let it run for about 45 minutes, and then we'll let them air cool. So we've been letting these parts soak in here at around 800 degrees now for about 45 minutes, which should be good for the tempering process. The whole idea here is you heat it up, you quench it, that makes it super hard. You heat it up at a lower temperature and just let it cool down, and that's going to kind of soften it so it's not super hard. We don't want these so hard that they're brittle. We want to kind of make them tough. So this should get the job done. I've got some fire bricks up on the top here. We're just going to pull them out and let them sit up there and let them just cool down in the air naturally. So this cycle's over. I'm just going to go ahead and turn the furnace off. We'll open up the door, and even though they're not red hot like they were before, these are still very, very hot. So we'll just put them up here and let them cool down. All right. So we'll just let these cool down naturally overnight. It's about 5 o'clock right now. I'll come in tomorrow. These should be cooled down to temperature. We'll clean them up, take them over to the grinder and start grinding them. So it's going to be overnight for me, but for you guys, it'll be just a few minutes. Well, I got a good night's sleep last night. I know that was a short break for you guys though, but it is the next morning and these parts have cooled down. I did take them over to the wire wheel and just kind of knocked a little bit of that scale that was on the outside of them. Most of that was just from where we dipped it in the oil and then of course heated it back up in the tempering process, but it's really not that bad. There's really not a whole lot of scale or anything on these, but we're going to be grinding these surfaces anyway, so it'll be cleaning those up. They'll look real nice. One thing I want to do before I grind them is get an idea of how hard these are. I know my blueprints, I think, said I need to be a Rockwell C 48 to 52, shooting for a Rockwell 50, I think is what it was at. But I've got a little hardness tester. I'm just going to hit a little spot on one of these and just kind of get an idea. My hardness tester is not super accurate. It kind of gives me in a range, but it'll tell me if I'm in the ballpark on the heat treat on these. So let me do that real quick. My hardness tester is made by PTC Instruments. It's a Model 316, and basically it's a pretty simple little setup here. There's a calibrated self-doing center punch here. You just spring loaded, and it has a tip on here that's actually got a round ball on it. And that, when you push this down onto a surface, it will make a little dimple in the surface. And then you look at it through this little microscope looking thing that has a light, and you look at the size of the indentation. There's a scale in there, and you just kind of look on there, and you can get it within a couple of points on this hardness scale. So anyway, I'm going to do that real quick and just kind of see where it's at. Like I said, this isn't as accurate as some of the more expensive, fancy hardness testers, but it's going to get us in the ballpark, which is all I need for this. See how close it is. Got my part over here in a vise, and I'm just going to take this center punch, find me a spot on here to do it, and we'll just, that made a little dimple right there. Now I'll take this and kind of put it over that dimple, and I just kind of look down through the microscope here. I'll kind of line that up. All right, so looking at this, looks like it's between, I got a line at 45 and a line at 50, and it's kind of between that 45 and 50. So, you know, we're close to where we need to be. 48 to 52 is what it was saying. It's going to be around that 48 number, maybe just a tad bit under that, but close enough. Close enough for what we're doing. So to grind the tapers, I'm going to use my Brown Sharp number 13 universal tool and grinding machine. This is a fairly new machine for me in the shop. In fact, this will be the first real job I've done on it. And one of the nice things about this is you can turn the table to whatever angle you need within its range to turn a taper. And that's exactly what we're going to be doing here. One thing I'll note, I had done a video on this machine previously, and one of the things that I actually did a video on was making some new knobs or stops for here because I couldn't find the original stops, or this machine didn't come with the original stops. Since I've done that video, guys, look what I found. A set of original stops that go on this. And I'll show these here in just a minute, but interesting little story on how I found them. I was perusing on eBay one day, and I had been searching for, Brown Sharp 13, and I noticed that there was a seller, actually a machinery dealer, that had posted a bunch of parts for one of these machines. And actually, one of the items that he had, I ended up buying. But I sent them a note and I said, hey, you know, just curious, it looks like you may be parting out a Brown Sharp number 13. I'm looking for these stops, and they each text or sent me a message back through eBay, said, yes, we are parting one out. Let me look and see if we have that part. They had the part, and basically they put them up for sale on eBay at my request. Sent me a message, told me they were putting them up there with a buy it now price on them, and then I bought them immediately, probably before anybody else ever even had a chance to see them. But I found the original things, and I knew that I would eventually do it. I didn't think it would be as quick as it was. But let me just zoom in here and show you these real quick, because they're kind of cool how they work. So first off, this was the one that I made. Basically, there's a T-nut on the back. It fits up in this slot, slides back and forth. You just tighten this up and down, and you can have a screw here on the front that you can use to adjust in and out. So these worked, but these here are really cool because you can't see it right now, but there's a rack in the back here, like a straight gear. And the way these are designed is they're spring loaded. You pull it out, you can slide it in and out, you push it in, it engages that rack, and then there's a screw here that you can screw in and out for fine adjustment. So when you pull this out, you can kind of see the back side there. There's your little spring-loaded piece right here that lets you pull it out. There's the little rack teeth that engage the rack. And again, you put it in there, you pull the spring out, it pulls the rack out. Whenever you release it, the spring engages into the rack and locks it in place. Kind of cool, quick adjust, and better than these, but again, these worked. So anyway, if anybody needs a set of those, I'll make you a deal on them. So down here on the end, there's a gauge that you can dial in the taper in inches per foot. We're going for a 3.5 inch taper. My scale only goes up to 3 inches. So it will go out beyond that, but the scale only goes out to 3 inches. So we get kind of estimate, but then we're going to have to fine tune it. So I'm going to loosen up the clamps here on the end. There is a bolt right here in the center. This is where it pivots in the middle, and there's also, I think, some clamps down on this end. We'll loosen these up as well. Now that will allow this whole table to pivot, and there's a screw here on the front that when you do it, if you can see, it's actually rotating the table. So let me get this cranked out roughly where we need to be, and I'm going to get an indicator. And this one up here, I just did on the taper attachment on the lathe, and I measured it on the lathe. It's real close. It's not perfect, but I can run an indicator on that and at least get close. And once we start grinding, we can make some fine adjustments to the table until we get it right where we need it. So give me just a second here. You can see the taper gauge here. It's a little bit hard to read, but we're coming up on that's 1 inch per foot, and it looks like we got gradations in there along the way. All right, let me get this cranked on out, and I'll be back. All right, I've got the table swept over here to roughly 3.5 inches per foot, and I've got my standard here. Again, this was done on the taper attachment. It's close. It's probably not perfect, but it's close. But this is going to give us a starting point to kind of get this in. The idea here is that when I get through grinding this will be a perfect taper, and I can use it next time to set up just like I'm doing here, but it'll be ground in just right. So I've got an indicator set up on there. When I sweep the table is coming in and out, but obviously the parallel to the ways, but the table is tilted over this way, but this back side should be right parallel to the ways, and I got the indicator on there. I'm sweeping it. Very little movement on the indicator as we moving down through there. So that's telling me I'm really close to where we are. I think what I'm going to do is get one of the actual collets. I got a little bit shorter range. I'm going to look at it, the collets that are already ground, and kind of use that to fine tune the setup here. So let me go get one of those and put it in there, and we'll go from there. So I got the collet in here, and again, that's an original collet, and I'm just using that to fine tune this. I've made a couple of adjustments. So we'll come out across there. Of course, it's going to jump down right there when it gets in that little gap, but then it's going to come back up to 0 or pretty darn close to it. I think the repeatability when I go through that valley, it's bumping around, you know, just a tiny amount, but I think we're real close. I'm going to go with this setup. I'm going to be able to measure it with my taper micrometer, and we can, if we need to make some fine adjustments, once we start grinding the standard, we can. Once we get the standard set, I think we'll be good to go. And the idea with the standard later on is I'll be able to sweep a longer segment, which will just make my accuracy better than I can on this shorter piece here. But that's the size that we're doing, so that's going to be a good setup tool there. My next step is I need to dress this wheel. This is a brand spanking new wheel. It's never been on this machine. It's never been ground into the arbor that it's on, so we need to get that basically just trued up. So I've got a little tool holder here that's holding a diamond nib, and we will just go back and forth and get that wheel until it's nice and dressed. So let me fire the machine up. And pull our cutter in. Bring it in until it just touches off. All right, I saw a little spark there. And we'll go back and forth. I'll feed in a little bit. I see it's all a little line on there. I'll make sure I got a good grind. All right, that wheel should be turning free now. I'm going to shut the machine down, and we'll get our work mounted back on here, and then we can start grinding. I got a little problem I'm running into here, nothing we can't deal with, but as you can see, the table is tilted back pretty far. And the way it is right now, by the time my wheel comes in here and starts engaging the work, the tailstock is going to be running into the pulley over here in the back. And so to fix this, no big deal. I can actually rotate the entire head on here. When I do that, I'm going to have to regrind the wheel because now the wheel will not be running parallel to the grind on the wheel will not be running parallel to the table. It'll be at an angle on the wheel, but it needs to be running parallel to the table. So let me make a quick adjustment here, redress my wheel, and I think we'll be ready to go. All right, I have loosened up the bolt here that rotates here. There is a degree scale down here on the bottom, and according to my degree scale on the table, it's about 8.5 degrees. So I'm just gonna, well, let's see what I gotta do to rotate that. There we go. Just had to get on the other side where I had a little more leverage. And this doesn't have to be exactly the same, but we're gonna get it about 8.5 degrees, just so that it's roughly the same, and there it is. We will tighten this nut back up again. And now the head is at the same angle, and like I said, I need to redress my wheel to get the right grind on it for this angle. So I've got the angle ground on here now, but that is, again, running parallel to the table because this head is tilted. It's at an angle, but again, no big deal. We got our work. Our center here is spring-loaded. I'm going to put this in the center on that end. We'll engage the center on this end. I got the drive dog in there to drive it. And now, I think we're ready to roll. I need to adjust my stops on the table. But other than that, I think we're good to go. So let me get this ready to roll. We'll get that stops set, and we can start grinding. Well, this video is getting a little bit long, so I think we're going to go ahead and just cut this one off here, and then we'll pick up where we left off on the next video. So guys, as always, thanks for watching. Please subscribe to the channel if you haven't already. Those thumbs up, those comments, they're greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. Big, huge thank you to those who support the site financially through Patreon, PayPal, and YouTube memberships. It really does help out around here a lot and really does enable me to take the time to shoot these videos and bring them to you. And with that, guys, we're going to sign off. We'll catch you on the next video. Again, as always, thanks for watching.